What's up, lads? Back at it again, May 26th, 4 p.m. Let's get right into it. I am working on computer architecture. Uh, yeah, I was learning more about it, learning the foundational concepts, and then I really want to get that shit done so that I can move on to other things. But I mean, you can't rush process, right? You cannot rush progress because learning is learning. You can't rush it. Yeah. So let's do it. Let's do it, do it, do it. Um, yeah, today's question is a hard one. I don't know if I want to do that, bro. Let's do what question do I want to do today? Um, let's do let's do a map question. Cause cause let me tell you why I want to do a map question. Cause if you look at this, um when I do implement the let me show you. Open PCAP files, right? This is the this is the project that I want to do, which is parsing uh the high frequency data, right? So, and then what I did initially, if you check out my GitHub, I followed this. So the WK self guy. So I implemented it as a tree. But that's not what you're supposed to do. See? Replace BST with a map for price lookups, and then use a binary heap or priority queue, which is a heap, to track uh bid ask. Booty camel. This I don't know what that is yet. But yeah. Um says BST is bad. Maintaining a sorted structure with a heap. And this is like this standard order book map idea is also consistent with a Reddit post that I read. Uh order book implementation. What thing was this? No. I forgot where it was. I think it was this. That's pretty cool. Um, was it not here? Order book implementation. think it was this, right? Yeah. So this one. Um, let me save this first. Yeah, I did save it. So yeah, think of it like a ladder of levels with map, right? Yeah, and that's actually the price. That's the actual price, I believe. Best. What was BBO again? Best bid offer. Ladder begin as my best price. Yep, that would be pretty interesting. But yeah. Okay. This is pretty interesting actually. Oh, hello. Ừ.你有蛋撻嘅話，可以買個蛋撻咯。Yeah，唔使咯。Thanks. Bye. Okay, yeah, so this is what you want to do. That's pretty interesting. Um, so it does say using a linked list. But this guy says when you use your own allocator property, would mm, um I'm not sure I understand what's going on because I'm not really reading into it that much. But I guess I'll just do a link to this question because it's just a lot of list stuff, right? So I'm just gonna do that, I guess. Um, I don't know. Let's do a random one. Not looking, not looking. Boom, this one. Okay. What? You will not be given access to the first node of head? Guarantee that the given node is not the last node in the linked list. Delete the given node. Note that by deleting the node, we do not mean removing it from memory. We mean the value of the given node should not exist in the linked list. The number of nodes in the link should decrease by one. All the values before node should be in the same order. All the values after node should be in the same order. Okay, so the cheese is how do I find this node, right? How do I find this node? The fuck? So the first node, some node has value next pointing to this node. I don't know what the cheese is here. Interesting. But let's see what. Excuse me. How do I find the previous node? How to find previous node of singly linked list? How do I find it? You can't. What? So if I just set this to next, then it'll work? Does it work? No way this works, right? Why though? How? So I'm just pointing to the next one. What? Okay. Mm-hmm. Okay, well, this is pretty cheese. Let's do another one, I guess. Boom. Internally, position is used to denote the index of the node that tail's next pointer is connected to. Is this a fast slow pointer? Question. If head next equals to null pointer, then return what? Return null. Right? Else, passive, uh, fast pointer equals to head next, right? And then, um, while while fast is not equals to null pointer, right? Exit case will be if fast equals to head. And what that would mean is you'll want to return what? If they're not equals, head equals to head next. And then fast equals to fast next. next, right? Mhm. Or head equals to null pointer, right? Use return null. So there are at least two. And then and fast next is not equals to null pointer, right? Then I can keep going. And here I'll return null. Think that'll work. Hmm. For a long, long time. Head is here, fast is here, they're not equals. Head is here, fast is here, they're not equals. Head is here, fast is here. Uh, head is here, fast is here. Oh, I have to return where they're connected, not where they're equal. Oh, right, right, right. So it's not a fast low pointer thing. I see. I see. This is interesting. Um, I traverse it. Right, I can do another linked list. I'm thinking, Hmm. It's not where they're meeting, it's where they are. So I don't think it needs two pointers. Okay. Don't think it needs two pointers. So what we're doing is, I think, creating a new list. Um, and then what do I do? Can I have a set of pointers? Does that work? So I could do a set of pointers, right? Of list node pointers, right? Scene, right? Okay. And then while head is not null, um, head, no, and then scene dot insert head, right? And then if, no. If scene dot contains head, then return head. Head or equals to head next, right? Here, return no. Does that work? It does. Holy shit. So I can actually do a set of pointers. Yeah, that's kind of genius, no? No. Do this. No? What? Member access within no pointer. What? Does this work? Hello? Ria? Hello. Excuse me. Okay. So how does that work? Let's see. Okay, so it is a fast slow.
喂，點知有啊？有啊，點知又有？有。
So my initial thought was correct. So they do intersect here, then I will reset it to head. Why would they meet for sure though? Sheesh. Okay, my initial thought was correct, but I just didn't get the last part. Like to reset the slow and fast. Slow fast, fast, slow, and then they'll meet at -4. And then you reset slow here, fast here, and then they'll converge. Slow, fast, and they converge here. Really? Okay, I guess. Like what if it's 4 back to 0, right? What if it's 4 back to 0? So there's slow, fast, fast, and then slow will be here. And I reset it to head. And then move one. Fast will be here, slow will be here. And then fast will be here. Slow will also be here. Wow, how does that work? That is kind of fascinating. I see. Well, somehow by some magical shit it works, which is cool. It clearly is much quicker than my solution because it doesn't use the set stuff. But yeah, interesting anyways. Doing some limitless question today. I will catch you guys tomorrow and get back to my computer architecture. Bleh. All right, peace. See ya.